Morning, everyone. Good morning. So it's 9:30, so it's time for the session to get started. This is the ACE session. If you're not here for ACE, please take your conversation outside. If you are here for ACE, stop your conversation. So yes, we're here in London, IETF 101. I'm Ben and Jim, my co-chair here. So let's get started by handing out the blue sheets. And since this is the first session of the week, everyone should take care to note well the note well. This is actually a slightly new text for this meeting, but the basic content is the same if you are already familiar with the IETF note well. All right, so we've got the agenda up, and there's some time for agenda bashing. If anyone has topics they would like to add or topics they would like to remove, you should come to the mic now.
This is Hannes. I just wanted to note that there's a side meeting during lunch about the topic that is related to the work here on sort of application layer DLS. I was sent to this Atlas mailing list. I can forward the logistic information to the ACE mailing list if someone is interested.
Yeah, I would say go ahead and forward the information anyway, just in case. Okay, so I think we can move on to the status update, which Jim and I will take care of. So this first bullet point might look a little bit familiar to those of you who were in Singapore, but it turns out that I'm going to be starting as security AD in a few days, so I will not be able to be chair anymore. But thank you to Roman, who has offered to step in and take over for me. I'm sure he'll do a great job. And the next item is also pretty exciting. So the core CBOR web token document has been approved by the IASG, and it's, I guess technically it's not quite in the RFC editor's queue because Mike is going to be submitting a minor update, but it's basically done and we're going to ship it. And the other updates since Singapore are that we adopted a couple more drafts. So we'll be happy to see more work on those and get them to mature. So next up are our presentations. So I believe Mike is up first.
Good morning. I'm Mike Jones from Microsoft. I'm here to talk about the proof of possession key representation for the CBOR web token. Next. Oh, there we go. No, it's not advancing.
Try again.
Better. So since we last met our heroes in Singapore, we've published one new draft which addressed a few comments on really formatting, not content, that came in the meantime. During that draft, we also looked back at Jim's comments from 0.0 and tried to address the rest of them that we understood how to do in a straightforward way. Jim, looking at the email, I think you still owe suggested text on a couple of them if you want to pursue those. And there was one where you asked to like restructure the text in a major way. And maybe we can talk about that. But what we had done intentionally was have the sections and the definitions follow the JOT proof of possession draft, which is RFC 7800. One of Jim's comments asked to sort of change the structure of it, which we didn't do. Other than that, we believe that this is essentially done. At IETF 99, we agreed to try to do this fast because it's a simple draft that just is effectively a syntax transformation from an RFC that already exists, from JSON to CBOR. As the chair has just noted, the CBOR web token is now in the RFC editor queue. They're right that I will publish one draft which just adds the same phrase in a few places saying, as defined in section such and such, so no actual changes. At least the editors believe that this is ready for working group last call. There's been no semantic changes to it during the lifetime of the draft. There have been improvements in exposition, and I expect that in working group last call, we will continue to get suggestions for improvements in the exposition. The reason I believe that it's also timely to get this out is that a bunch of the other ACE work, which uses proof of possession, counts on this draft, just like they count on the CBOR web token. And that's obviously a decision for the chairs and ADs, but we feel like it's essentially done. That's all I have.
Thanks. So next up looks like Peter.
If you wish. This is the IETF of Co-op S draft, which has recently been adopted as a working group draft. Thank you very much. I appreciate that. What it does, it tells you about enrollment of over secure transport, but instead of using the standard TLS, it uses the DTLS, and that is done for constrained devices. There are two application areas which are clear at this moment for this draft. One is for the brisky, for all the bootstrapping, which is coming from the Anima and also be transported to 6-stage. And the other use case is that one likes to do the enrollment for a client to a server of all the keying and certificates. So two separate use cases. There has been major progress. Yeah, the most major progress is that the draft has been separated in parts, where before it was very much focused on the brisky extensions. They have all been removed, and it is now purely IETF Co-op S. Thank you, Hannes, for making this possible as well. So what this draft does is just IETF Co-op S and all the other extensions, like what is the voucher stated, etc., used for brisky, is done to another draft, which is currently being presented to Anima. Further, we used an...
You have a display in front of you.
Oh, life is so simple, as you know. Okay.
We're living in luxury.
This is fantastic. Yeah. Oh, yeah. So Michael actually giving all these vouchers and all these different ways of handling the bootstrapping. He has made a nice diagram, which I will try to show you. Otherwise, the URL is URI is mentioned here. I'd like to thank Benjamin, Jim, and Hannes for all the comments I already got on IETF 0. They really helped to go to the next version. So, what are the current issues with the IETF 0 one? The proxying has to be clarified. I mean, we have synced some complications with what is actually the terminology to use in the case of EST and not just thinking about this is ATP co-op. So, but I think that is going well. Further on, we have to look for the forward compatibility sanctions for the DTLS 1.3 versus the DTLS 1.2. One of the points is that in EST there is this point that you wait for an HTTP 202 because you ask for some information and it may take long, a few hours before the information actually comes back. And that we have tried to have in the core pending documents, which is currently being proposed in core, but it's needed. Then there was the suggestion that the server key generation may only use COSE, and we are not determined about how to do that yet. Then there was the suggestion that we have these long names and the short names for the functions and the operations, and that we will use a may and a must as is suggested.
Peter,
Yes.
could you explain a little bit the server key generation? Because there's also that functionality in EST itself, but I think in today's standards, that's not really a good security practice anymore to generate public-private key on the server side and then send it to the client.
Okay, as far as I know, from one of my co-authors, that they wanted to use the server key generation for one of the applications. And so for that reason, they thought it was important. But they were concerned actually about how to actually protect then the transport of this new generated key. And they thought that it could be handled by having the keys already pre-distributed there. But that's just what I understand.
Who is that co-author?
Panos.
Cisco. Okay. That was a Cisco guy.
Pardon?
I know.
No, Panos is a system. Yeah.
Okay. Interesting.
Yeah, well, yeah, the server-side key generation. Sorry, this is Max Burdikin. Whoa. The server-side key generation was brought in for the RPKI work because they were doing a distribution. Sorry, is that better? Okay. The server-side key generation was brought in for the RPKI work because they were doing distribution of the keys, and the method they were using to, Brian might be able to explain better, the method they were using to distribute the public key information had a 24-hour lag or something like that. So the way they wanted to do that was to bring up a replacement router, and they wanted to be able to distribute the key, the private keys for it that matched what had already been distributed via the RPKI mechanisms.
So you think we should explain this use case a little bit more in detail?
Quite possibly, or
Okay.
check with them about
Good.
whether that's still a
Excellent.
concern.
Yeah. Any other remarks? No. Then there are some things we want to do. Putting in some operational parameter values, which are still open here. Also, how to do the server key generation, how to implement that, and explain again for the HTTP co-op, or if you like the EST RA, how the trust relations will exist. So that has to be explained in more detail. We think that we can do all that before IETF 102. This is not a promise, but I think it's possible.
I'm always a little bit reluctant to believe that these fast timelines. That I was wondering whether you could, for example, this co-op response code. So if unless there's an absolute need to create a normative dependency, it's probably worthwhile to keep that separate in some sense.
Yes, we do. For the moment, we like to keep this separate. Yeah.
Yes, so not just in a separate document, but also not having a normative reference.
That's
because
I thought I already did that. It is informative reference. Yeah.
That's good because even though it's a very simplistic document, because it just registers a value, but that doesn't mean that it doesn't take years. The other things, because there's an interest to use some of that basic functionality in deployments today, and so it's better to get something rolling out and into the deployments rather than waiting for inclusion of sort of some more esoteric features that maybe could covered in a separate document once people figure out what it actually is.
Okay, we'll monitor the progress quite tightly and see what we can do with that. Thanks for the suggestion. For people who want to look at it, this is the diagram produced by Michael, which tells you the different environments in which Brusky is used and what kind of vouchers you may use, done in JSON or in CBOR if you want, etc. So I encourage you to look at it. It is very interesting. And that's all. Yep. Questions, remarks? No? Thank you very much.
Goran's coming up. And just as a reminder, if you do come to the mic in the middle of the room, please remember to say your name before you start talking.
Okay, hello everyone. I'm Göran Selander from Ericsson. And I'm going to talk about an update of a draft of another name. So we rewritten a draft called the EALS, the Enrollment Using Application Layer Security. And the content of this new draft is essentially described by the title. We're protecting ESD payloads using OS Core, ESD OS Core. So in the virtual interim meeting, the second virtual interim meeting last fall, we discussed the different enrollment drafts. The work group was supportive of the EALS draft, but proposed it should be better aligned with EST in general and EST Co-op-S in particular. And that's the content of this draft. So it's very similar. EST Co-op-S that Peter talked about is doing EST payloads transported with CoAP protected with DTLS. And this is doing the same thing, but protected with OS Core. And that means that most parts of the EST Co-op-S apply directly to EST OS Core, like the message types, message bindings, fragmentation using blockwise, the CoAP response codes, new content formats, shorter URI paths, etc. But there are some differences. And the main difference is that OS Core, EST OS Core allows different ways to establish keys. So whereas EST Co-op-S relies on a DTLS handshake, EST OS Core allows either pre-shared keys, the OS Core profile of ACE, or a key exchange to be defined. And the point with actually separating the key exchange protocol from the communication security is that for certain enrollment scenarios, you don't strictly need perfect forward secrecy for the enrollment request. And the handshake, the DTLS handshake or any key exchange will have a large overhead. And therefore, if it's not necessary in certain constrained environments, you may want to use some other mechanism. Another difference is the discovery. So while the discovery is the same, how you indicate support for OS Core is slightly different. So there is an attribute defined in the OS Core draft. And also proxying, I mean, you could say it's both similar and different. You could do proxying in the same way that you do hop by hop from the EST client to a CoAP to HTTP proxy, and from the proxy to the CA. Or you could do it end-to-end from HTTP, from EST server to EST client. And that's essentially it. So was this the change you requested in the second interim of ACE? And are you happy with the changes? Any other comments? Are you still supportive of this draft?
So can we get a show of hands in the room of who has actually read the updated draft? It's about 6 or 8 people, I think. So it would, of course, be good to get more eyes on the draft. If people could try and read it. Okay, so I think Ludwig, you're up.
So I'm going to swat 3 flies with one stroke. I'm going to talk about 3 different drafts in one presentation. The first one is the OAuth draft, which I'm going to call the framework in order to not get a knot in my tongue. The second one is the DTLS authorize, which I call the DTLS profile of the framework. And the third one is the OSCORE profile of the framework. Next slide, please. Or I can use that. Yeah. Thank you. So updates. Last IETF, you saw version 08. We did 2 updates, and in the next few days, I'm going to upload a 3rd one, thanks to Jim, who found a few errors that escaped me and my co-authors' vigilance. What we did was we went through the IANA section, which was a mess, and unmessed it, hopefully. Then someone, I think also Jim, noticed that the scope claim was defined as a string, and that you might want to have that as a byte array as well, if you have compact encoding. So we changed that to allow that. Then someone, I think Eric or Samuel, introduced default names for the introspect and token endpoints. We removed the client token design after discussion on the mailing list, which you probably are aware of, or most of you are. So we are thinking whether that should go into a separate draft or not, if there is interest in the working group in that work. I won't do it just for show. I mean, if someone is interested, I am happy to do it, but I'm not going to do it just to let it die. And finally, Hannes did some work on clarifying the possible use of HTTP instead of co-op. It was allowed since many versions back, but it wasn't 100% clear, and there were a few inconsistencies in the text from an older version where we just talked about co-op. So Hannes did a few updates, and now it should be perfectly clear that if your use case is more suited for HTTP, you can use ACE with HTTP as a transport protocol. Okay, that's the framework. If you're okay with that, I would like to go on, and then we can collect questions on the whole thing, because the framework is really not that meaningful without the profiles. Otherwise, if you have questions immediately on what I said, now is the time. No one rushing to the microphone, great. So the detailed profile got updated from version 02 to version 3, mostly Olaf's work. I tried to help a bit. We did clarify how the client detects whether this profile is using the pre-shared key or the raw public key mode. It wasn't 100% clear. We got a review comment. Olaf added some text that clarifies how this is supposed to happen. Then there was some parts of how the PSK identity is used in the PSK case, and we did clean that part up. So basically what the resource server is expected to do is, if it gets a PSK identity in the TLS handshake, it is to try if that is a key identifier first, of a key it already knows. And if that fails, then it should check if the PSK identity is actually an access token containing a key. So that wasn't 100% clear in the previous versions, and we clarified that. Then, much to my distress, I may add, Olaf added the requirement of supporting the ed curves in raw public key mode, and I currently don't have a library that supports that, so I'm a bit distressed by that, but it will be solved eventually. Currently, my code is not...
and I want to
go ahead. Hannes, who are you?
On that one. Hannes, yeah, I'm not, while I like all this work on Curve 25519, I think it's a little bit a rush to mandate it right away, because all the other documents still say that the mandatory to support is the NIST 256 R1 curve, and maybe have that as an option would be appropriate, but not the mandated version, because that would also be an issue for us.
You're going to get an answer, I guess, behind you in the queue.
Olaf Bergman. I basically added that because I proposed it back at IETF 99 in Prague and no one objected. So I took that as consent to add that.
Hannes, my memory is not serving me well right at the moment.
Me neither. And
Do you remember what the mandatory to implement for TLS is? TLS 1.3?
in 1.3, it talks about, same as 1.2, it talks about, those are sort of the recommendations for the web space, and ask for, and maybe other application profiles. And that's what we did with 1.2 in this DTLS, TLS IoT profile. Thomas, I don't know if he's here, and I submitted a document, first version for such a profile for 1.3, where we essentially mirror what we said for 1.2. There, it talks about a number of algorithms which I haven't yet seen widely implemented in various embedded devices. So it takes up a little bit longer because also the hardware functionality needs to catch up. So like we are a little bit in a rush there. Like it takes the chip manufacturers to take time to put the hardware functionality in there.
Ben Kadek, I just checked the TLS 1.3 mandatory to implement. Looks like it's still P256, and X25519 is should.
Yeah, not so, that was what I was going to say. But I think if we don't mandate curve 25519 now, when are we going to do it? And we should have a plan for that. I think we should try to use both for a transition phase.
Yeah, understand the ambition. But it would be sad if then none of the implementations actually support, even comply to the specification. So maybe having some transition phase, like you just read, for the TLS 1.3 phase, that would probably be a good idea. There's also, when we talk about AES versus the Cha-Cha Poly, and that falls into the same category. We don't have, I don't think we have a Cha-Cha Poly implementation either.
I mean, Hannes, the positive thing about mandating it would be we will force people to actually implement that.
Well, that's an experience I will talk about that suit, Bob, about how well that works.
Carsten Bormann, we have a number of mandatory to implement the specifications in the CoAP specification. And the CoAP specification was completed in 2013. So after about 5 years, it's maybe time to revisit that. And I would expect that we want to do a combined effort between all the working groups that actually have a chip in this game on doing the next set of crypto algorithms that we recommend. And of course, behind the horizon, there's also the whole idea of going to Keccak-based mechanisms for the symmetric part. So that might be another disturbance that we might experience in that space. Maybe the whole concept of mandatory to implement is a bit less useful in this environment than it is in other environments. And so we probably want to modulate this a little bit based on this observation. But again, more importantly, we should start a concerted approach to revisit the algorithms that we use as mandatory to implement in all those documents, including 7252. And we probably want to do a kernel-like process for doing this.
Olaf Bergman, I completely second what Carsten just said. And there are open source implementations of the at 25519 curve. So you have code to look at, and I've been told that it's even easier to implement correctly than the 256 curve is. So from my point of view, it pretty much makes sense to start moving to that curve now.
I mean, we need to get it into the DTLS implementations. That's, I think, the bigger step. And since those are libraries that have a process for adding new features, this might take a while.
Janusz Volat. I completely agree. I'm working on a TLS stack, and it takes some time to integrate these features. So personally, I'm a big fan of this curve, and it's true, it's easier to implement correctly than other curves. But while these needs to be newly implemented, other curves have been already implemented in many TLS stacks and been tested both in practice and in test systems for years. So which one would be best and which one is more accessible? That is a good question. And what is our goal with mandating this curve? Providing security, yeah, then it's achieved and it's good. But it can be a barrier to adapting the standard because IoT devices usually are on the long tail, and it takes much more time for them to adapt new algorithms and new profiles like this. Thank you.
Okay.
We'll probably want to continue the discussion about the algorithms and curves on the list.
Yes, it would be good if we could make a decision on that on the lists rather soon so that we can adapt our implementations accordingly. So let's not forget about that. Next point, we made some clarifications in related to Appendix C of the framework. Appendix C of the framework basically summarizes all the requirements that the framework makes on profiles. And it turned out some of these requirements were not clearly represented in the DTLS profile. So we made some updates to clarify which parts fulfill which requirements. Yes, Carsten?
You just said a sentence that I think needs to be interpreted. Let's make a decision on that on the mailing list.
Yeah, that was what I meant.
Yeah, I don't know what that is. But if
whether to have this as a mandatory to implement or optional and what to do.
Yeah, what I was trying to say in my previous contribution was that this needs to be coordinated.
Yeah.
It's not the ACE working group that will decide what the next set of cryptograms is. So it probably would be a good thing to actually start coordinating this now.
John Mattsson, +1.
So who should we coordinate with then? I guess TLS is a good start, but who more?
John Mattsson, I think it needs to coordinate among the IoT groups. I think the general profile for TLS might be quite different from what IoT does. I think it's ACE, core. Yeah.
Okay. Yes. Next one is a placeholder that remained a placeholder. We were planning to do some plug testing, but I arrived late and we had other things that we needed to do. So we planned during the week to plug together a few implementations and see what happens. There are, I think, 3 implementations present in the room. And there is a 4th one which will come to us at IETF 102. I'm going to talk about those in a moment. Next steps, well, we need to gather more implementation experience. Obviously, we have a number of implementations that interoperate well with themselves, and we need to check how they interoperate with other implementations. That's what we're planning to do. We want to add examples of how the different parts of this profile are planned to look like, and we need more reviews. We've had a review, if I recall correctly. Was it from you, Jim? Yes. So more reviews, please. Any volunteers? Well, there were a lot of people volunteering to review the last few meetings. I don't know if it was specifically on this profile, but on the ACE framework, there were a lot. If we can recall who those people were and remind them, that would be a good start. Next profile is the OSCORE profile. So basically, while the DTLS profile described how you use DTLS to connect to a resource server and optionally also to the authorization server, this one describes how you use OSCORE to connect to the resource server and optionally the authorization server. And here I discovered that we hadn't mandated that the token was to be encrypted. And since OSCORE is a pre-shared key profile, you're going to be sending a pre-shared key in the token to the resource server, and you better not want that to be visible. So I added a sentence that if you send a CWT, you need to have it encrypted so that the listener on the line doesn't capture the secret key. Next thing, it turns out even here, it wasn't completely clear how the proof of possession was supposed to happen. Basically, it's implicit because you generate an OSCORE context from the confirmation key. And then if you can decrypt the message, then you obviously have the right secret key. So you can prove that you have that by just being able to read the OSCORE messages. We added some security considerations. It's a first version, so this one probably needs to go through a number of reviews and revisions. And I added a long section with IANA considerations. And given my track record on messing those up, we would also need reviews on this document. So people who feel even more motivated, go ahead, read that. It's not a long draft, actually. It shouldn't take you too long. And provide us comments. And that leads me to one more open item. This is an old item raised by Mike Jones, who asked us in his very, very thorough review how this related to the token binding work at OAuth. And I kind of tried to throw the question back at him because I don't know token binding, and he is at least involved, if not a co-author, right? So I would also like to know how that is related. Any volunteers from OAuth to help us work that out? I can talk to you if you want, Mike, but anyone else is welcome.
Hannes and John are raising hands.
Is John Bradley in the room?
Yes.
No. Thanks for volunteering me.
I can bring you a microphone. No? Okay.
For the record, Mike Jones of Microsoft just volunteered John Bradley of Yubico and one of the token binding working group chairs to also look at this issue with us.
Great. Thank you, John. There was another point that I was thinking about, and I missed the meeting, so that's a bit bad of me to ask that question. But we had a meeting with OCF, who also have an access control mechanism in their standards draft. And I was wondering to what conclusion we came do we want to have, or do we have any relationship with OCF? Anyone? Yes, question. Do we have, or do we want to have any relationship to the OCF work? Any opinions on that? It would probably influence all of these drafts. So it feels like a good point.
Dave Taylor, OCF member, not speaking for the OCF. There's a meeting that we have on Friday, which I think is what Karsten was going to get up and say too. And this would be a great question for us to ask at that meeting, and some of us are going to be at that meeting. So in Prague, we're flying down there on Friday, and there's a joint thing-to-thing research group, OCF, W3C meeting that's joint on Friday afternoon. And the purpose is to coordinate what can be used across SDOs. And so we can put this on that particular list. And so those of us that are in the room that can be there, I say there's at least 3 of us, probably more in this room that will be there. And so we can put this on our list.
Great, great. Thank you very much. That was what I was trying to achieve.
Karsten, please stay up. Was there also a virtual meeting in January?
Yes.
Is that worth talking about?
Yes.
Did anything interesting happen that you want to tell us about? I don't think I made it.
Well, yes. So we at the last, let me start from the beginning. So we are doing these coordination meetings with OCF approximately on a half-year cadence right now. And at the last meeting, we decided there were some issues that actually would motivate having interim phone conferences. And the first one we identified was the relationship between the ACE security work and the OCF security work. So we started looking at that in that phone conference, but I wouldn't say that we came to a conclusion yet. So we have to continue this kind of work. It's just really hard to schedule between the different organizations with the different fixed points and so on.
Okay.
So I'm sure on Friday we will discuss how this work will continue.
Excellent. Thank you.
Great. So next steps. We've been through a number of iterations, at least with the framework, and I think it's rather mature. So I wanted to ask, is that a good time for a working group last call, or should we do something else before we do the working group last call?
Hi, this is Hannes. I personally think it would be a good idea to start with a working group last call, not only because of the implementations that you had listed up there. The interop testing this week is a little bit too ambitious, in my opinion, just coming from 2 days of hackathon and full IETF week schedule. But
you don't know what me and Jim are capable of when we're bored.
Let's see. Yeah, ambitions are big, and that's good. But at the workshop, our security workshop last week, I also mentioned that we have now released a product implementation of ACE OAuth, which we call Secure Device Access, and you can find the slides and with some material and pointers to the documentation in that deck. And so that would be, I think we need more products in that space. Implementations are good, prototype implementations are good, research implementations also, and open source code, but it would be nice if other companies also step forward and invest some time in product implementations and make those available, integrate them with the rest of their products.
And an ARM implementation based on Mbed, Hannes, that would be really cool.
You probably haven't listened to me, but I just said that we released the product.
You did? Great. That kind of escaped my attention. Sorry for that. Anyway, we're going to do some interop testing, which is basically we're going to plug together 2 or 3 implementations and see how they break this week, sometime between the meetings and so. There's going to be, hopefully, a bigger event at IETF 102. I know of 4 implementations that are going to be present at IETF 102, and since Hannes told us there's a 5th one, perhaps we can add them. Whoops. add them to the list here. There's one from us, RISE 6, that's me. There's one from Olaf, TU Bremen, TZI, University of Bremen, TZI. Jim Schad has some code on that. And then there is the SCI lab at Carnegie Mellon University who have a constrained implementation, which is great because I don't know if, yeah, Olaf's is probably also a constrained one, but mine is definitely not constrained. And Jim's, I don't know. Anyway, this is going to happen. Yeah, one more question just came to mind. I should have taken that earlier when I was talking about the progress of the framework. We removed the client token, and Hannes, you promised us a paper where you had analyzed the security of that approach. And I have still not seen that paper.
Yeah, this is Hannes. Because you're not carefully watching the OAuth security workshop, and
Okay.
it's actually published there, along with many other papers, which I think would be worthwhile to read. In fact, I've actually encouraged this community here to participate in the workshop. For me, it's always useful to get in touch with those guys, researchers who are doing formal analysis. And
you need to publish proper proceedings for us researchers to be able to come to your conference.
Working on it.
Great.
I can send the link to the mailing list.
That would be much appreciated.
Yeah, it describes. I did use two tools. I also briefly talked about it at the workshop. Avispa and Skyfer, and yeah, the stuff is in the document.
Yeah.
Great.
And I guess still on the client token topic, I think it's also a good chance to pause and ask if there's anyone in the room who does want to see the client token work continue on in some form, because I believe that's still an open question.
True.
The room looks very quiet, so
yeah,
maybe it's just going
rest
to
in
stay
peace.
removed.
Not quite, sorry.
Göran Selander. So I think there is a value which the client token, functionality the client token had, which we are missing. And it basically relates to things that has to do with client authorization, or what you want to call it. But it basically is the information going to the client about what it is supposed to do, and keys for doing that. So I think that function, basically, it's part of this this greater scheme of things, which is covered in the actor's draft, but only a specific case of that. So how do you actually, so a concrete example is if you look at the group communication, when you authorize keys for group communication, then you give typically rights for one device to access another device in the group. But you also would like to have instructions for the requesting device. Which other devices am I entitled to contact, or which resources on other devices am I entitled to contact? And that is not covered in the framework today. And it was, one aspect of that was covered in the client token. So I think that even if we don't carry on with the client token, I think the functionality, we should consider get that functionality represented somehow. Thanks.
Okay, I'm done unless there are more questions. I guess we're going to discuss the working group last call on the lists. Or
start with the chairs discussing it.
Yes, go ahead. Thank you.
Thanks. Francesca, there you are.
Hi, I'm Francesca. I am going to present two drafts. So the first one is this new draft, Palomini ACE Key Group Com, which is key provisioning for group communication using ACE. The motivation for this draft is from last meeting. So during last 3 meetings, we presented 2 different drafts, me and Marco. So one, the one about co-op PubSub, is a profile for group keying of pub/sub scenario, and the OSCOAP joining is a group com using OSCORE. So we got some feedback from the working group that about the similarities of those two drafts, and so we tried to create one document that describes the similarities, and this is this document. So what is in scope of this document is the message format to authorize a node to join this group communication and distribute the key material. And this makes use of the ACE framework and profiles. Out of scope of this document is how revocation of a group member is done and renewal of key, and what is the exact protocol that is used for group communication. So this is an overview of the participants in this new draft. So we have a client who is the node that is trying to join the group communication. The AS is the same as in the ACE framework. And we have a key distribution center that has the role to just distribute the group key material. The dispatcher is the node that dispatches the messages to the group members. And for example, in the COAP pub/sub, it can be the broker, or it could be implicit. So it could be, for example, a multicast IP address. In the first phase, the client, the client uses ACE, one particular profile of ACE, to communicate to the AS to get authorization to talk to the key distribution center. So in this use of ACE, the key distribution center is actually the resource server. Then we define a new set of messages to actually request key distribution to the key distribution center. So while this first phase is defined and it's very specific to what profile you use, then this one is currently not existing in ACE. So this, we try to use the same semantics, but this is new messages. Finally, the third phase, which is not in scope of this document, is the message exchange between the client and the group members through the dispatcher using the group key material that was retrieved from the key distribution center. So these are the details about what are the what messages, what is the format of the messages. So for the authorization request response, this is taken from the ACE again. The request must contain this grant type parameter and may contain a set of other parameters, and we specified in this document what each parameter contains. So for example, the scope is supposed to contain the group ID or the topic or something identifying the group communication and the role of the client. Role meaning, for example, in a pub/sub communication can be a publisher or subscriber. So we got feedback from Ludwig about use of scope in this way. The audience is the KDC because that's who the token is supposed to go to. And yeah, I just want to underline that we define a new parameter that is this get pub keys. This is the client sends this parameter if it wants to receive public keys of other members of the group. And then in the response, we define what needs to be sent. So the access token, what does the access token contain, and other information to establish secure communication with the key distribution center. And then these are the new existing key distribution request and response. So we define them as being similar to ACE, authorization request and response, even though these are not authorization request or response. But we still need some parameters that are similar. So we use the scope parameter, we use the get pub keys. Then we have new parameters defined, client credential, public keys repo, and group policies, management key material, etc. So we define exactly what these messages look like, and then group key communication have to specify which of these parameters are actually used. Yes, so that's the work we've done, and yeah, I think I can go on to the next one.
Ludwig Seitz, one question, if you could go back to the diagram.
Which one?
Where you could talk to the key distribution center. You were saying this message between client and key distribution center doesn't exist in ACE. I disagree. The key distribution center is just a resource server, and what you're doing is using your access token to access a resource at the key distribution server, which happens to be the group key and related information. So I'm probably just nitpicking here, but I think this is very much existing in ACE. It's the
this part,
resource.
yeah, of course, this part exists. But what I'm saying is this second phase with key distribution request and response, this is not defined in ACE.
Yeah, it's a resource access.
Yeah, it's a resource access, exactly. But we use the same semantics that we use with the authorization request and response.
Yes, true.
Even though it's not, the key distribution center is not an AS. But yeah.
I see.
Carsten Bormann. Yeah, so of course this is a nested set of protocols. So what is in RS in one step is the KDC in the next step. I'm intrigued by this get pub keys. I missed that so far. What exactly is the KDC claiming here? I mean, there are some public keys, okay, but what does it mean?
Yes, so the KDC can be also key management node, so it can store and then distribute the public keys of all the joining nodes. So this is each document using this draft should or must specify if the KDC is also managing the public keys. And this parameter is there to allow for the joining node to actually request the public keys if the KDC is storing public keys of all the members of the group.
Yeah, but again, what is the claim about these public keys? So apparently this is about a group. So this group must exist as a concept somewhere. And those public keys could be used for data origin authentication. They could be used for targeted encryption. There are different security properties you want to have here. These could be publisher keys. These could be subscriber keys.
Okay. Yeah, this draft does not go into that much detail. That would be like the drafts that use this draft that have to specify how they're used.
Okay.
Yeah.
I think we have to do that.
Okay. So yeah, I can move on to the COA pub sub profile. Maybe we can ask the questions later. Thank you. So just to remind, this is now version 02. This was presented in IETF 98 the first time. So I added some slides from there just to remind you what is the COA pub sub architecture and what are the roles of the endpoints that are, or the nodes and the participants in this draft. So the update to this draft is that it is now coherent with this new draft. So just a reminder, we have two authorization server, one AS1, AS2. AS1 defines what endpoints are allowed to publish to topic A on broker B, so it's access to the broker. And AS2, what endpoints are allowed to access topic A. So there are pre-existing security association between publisher and subscribers to both AS1 and AS2. And the goal is to set up security association between publisher and broker, and the second one is between publisher and subscribers. So this is the overview, and it's compared to the other draft that you saw before. So we have two different AS here. We have AS1, which corresponds to AS in the other draft, And then AS2 is actually one node that has both functions of AS and key distribution center from the other draft. So this is how this profile defines these nodes. Then we have a client that can be either a publisher or want to be publisher or subscriber. Dispatcher is the broker, and then the group members. So let's start with the publisher. The first phase is to establish a secure channel with the broker. So it's just a simple use of a ACE profile between publisher, so client, AS, and dispatcher. And the second phase is to retrieve the group key material at the AS2. So in this case, the same node is both AS and key distribution center, which means that there is no need to do the token post, and we can combine authorization request and key distribution request. So we take the parts of these messages that we need. And for subscriber, so as defined right now, there is no need to do profile with the broker, but just get the key distribution from the AS2. And finally, the third phase, which is defined in this profile, is to how the communication is protected. Yes, question?
I guess it's just a comment. This is Eve Mailer. I think where people were sort of, I was one of them shouting, that's an RS, not an AS before. This is maybe a clarifying concept that may help people, including me, understand your diagram.
Mm-hmm.
Because I think what you've got is you've defined a standardized interface for the KDC, which is a function of an AS, but you've OAuth protected it. So what you've got is you've got a standardized interface for a function of your AS that you've OAuth protected, and thus that KDC there is, it is actually an RS.
Yes and no, because it's not actually an authorization server. So it's a key distribution center. It does not do authorization.
Right. You've got an interior function of your AS that is an RS that you've standardized an interface for.
Yes.
That is OAuth protected. Am I right?
Yeah, I'm splitting the these two functions, the AS and the key distribution for group communication.
Okay.
So yes.
I've written a spec that has a very similar design pattern to that one.
Okay.
So, okay, just wanted to be sure.
Yes. So yes, this defines how finally the third phase that is defined in this document is how the communication is protected. So there is secure channel between client and broker, and then there is also messages protected with application layer security between publisher and all the members, so subscribers and publishers. So the last two slides are about how these messages match to the key provisioning group com draft. So so we have only two messages. So these are the authorization request plus key distribution request and authorization response plus key distribution response that are sent from client to AS2. And these are the details. And yes, I'm not going to go through all the details because you can read the draft and come back with comments for that. But that, of course, depends if a node is a publisher or a subscriber, if it's going to request public keys of the other members or not. And yeah, this is the same content that was in the previous, just adapted to this format. And yeah, that's it. So we got, I just want to say, we got quite some support for this profile and also for the profile that is coming after me. And yeah, we answered the request to make this more general format content by splitting or creating this draft that has the common material, let's say. But I wanted to ask if the working group is still supporting this work and if it thinks that this is a good way to approach this.
Thank you. As always, it's good to get more people reading the documents. While we have paused, if you have blue sheets next to you, could you just hold them up in the air for a little bit? I think there are a couple people who came in late and still need to sign the blue sheets. Do you have a blue sheet sitting next to you? Anyone? Yep. That'll be exciting at the end. All right, take it away, Marco.
Hello, Marco Tirolca, RI6. This is another update to the draft describing how to join groups where communication is protected with OSCORE, again using the ACE framework and its profiles. And this update especially followed direct actions we agreed to take at the last meeting in Singapore, especially out of discussions with Jim. Thanks for that. As you can guess, mostly related to the draft that Francesca presented before. So we needed to define the exact content of messages exchanged between the participants in the protocol, of course, aligned with the general high-level guideline we already provided in the main core document describing OSCORE group communication. And of course, we needed to address the similarities with the PubSub profile because they had a partial overlapping, and we didn't want to come to redefine or re-implement the same formats multiple times. So as a result, we produced that joint document, ACE-Key GroupCom, and in this document, essentially, now we have redefined all the protocol steps, specifying how the general message template from ACE-Key GroupCom can be instantiated specifically for this scenario. And with reference especially to the workflow we saw before, here the group manager in charge of the OSCORE group acts as a KDC in the generic model, and yeah, it is a resource server here. And instead, we don't have an actual participant node acting as a dispatcher. So especially messages addressed to the whole group are just sent to a multicast IP address. So essentially, we went through all the protocol steps and defined parameter per parameter, starting from the generic model, how each parameter is filled according to possibly structure. And especially the scope parameter in the authorization request is used by the joining node acting as client to specify most of the identifier of the group it intends to join and the role or set of roles that you would like to have in the group. The audience parameter instead points at the group manager, essentially its address. And get pub keys, here it is used, and we define how, again, in relation with the main core document. The group manager can optionally be configured also to act as repository of public keys of group members, then used essentially to produce digital signatures of messages sent to the group. So in that case, the joining node can explicitly signal that it wants to have the public keys of the members of the group at joining time. So that's the way this parameter is used in this case. And as we said, that's the new parameter defined also in ACE-Key GroupCom. Well, of course, the protocol continues with the authorization response, essentially, as described already in ACE-Key GroupCom. The X parameter must be present, and scope is present again only if there's a downgrade of roles, especially that are granted to the joining node to have in the group. And profile parameter, of course, has to be present to signal how communication is secured between the joining node as a client and the group manager as KDC and resource server in this case. Then the protocol continues, of course, with a token post on the group manager, the establishment of a secure channel if one is not already available, and then again the use of get pub key parameter in case of retrieving of public key nodes of group members from the joining node at joining time. Here we have a number of corner cases that are, of course, better documented in the draft, and already in the first place in the main core document. In case the group manager acts as repository of public key, the joining node has the occasion to provide for sure its own public key to the group manager, either directly or through as a certificate. And in this latter case, it can additionally provide the group manager also with a pointer to an external set of certification authorities. This is the most important part. In the end, it's how the joining node is actually provided with the key material that it requires to participate to the secure communication in the group. So most of it is part of the structured key parameter, where most of the parameters come already from the COSI RFC, and others we are reusing from the OSCORE profile base, essentially. We are introducing a new parameter, CSAlg, where the group manager essentially specifies the counter-signature algorithm used within the group to produce counter-signature of messages. Most of these parameters are optional, but in the end, it's about providing the OSCORE master secret in K, the endpoint ID assigned to the joining node in the client ID parameter, and the group ID in the server ID parameter. Then the message continues with, if requested, the public keys of the group members and a list of group policies possibly applied in the group, and relevant ones, better documented, of course, in the core document, are the approach to synchronize sequence numbers of multicasters in the group, or the specific recking protocol used to revoke and redistribute keys in the group, and related to that particular policy, the specific management key material needed to run and participate in the group recking protocol. And that specific content and format, of course, is related to the specific protocol used to rekey the group. So to conclude, this is now aligned with a new document describing the general format of key provisioning messages to support and enable group communication. It's also, of course, aligned with the intent and general guideline we already have in the main core document describing OSCORE Group Com. Speaking about also synchronization between multiple venues, right now this approach is the recommended one to join a group. The main core document indicates this as a recommended one out of a more generic description. So I wonder if we should consider this as something more than recommended one, as the way, or instead keep room for possible alternative approaches, so keeping also a generic description at a high level as well, but we can take that later. I just have this open question. Other than that, this document got support already in the past, and it was labeled as high priority at the ACE interim meeting end of last year. The big thing missing was especially having this alignment with generic message format description. So we wonder if it's eligible to be considered or is in a good shape for adoption.
Who's coming up?
Jonas Elander. So what we have seen is an interest to work on or to produce standards around group communication for simple IoT devices. And in that context, this draft was pointed out as one way of solving that. So I think if there are people here from Fair Hair Alliance who could add more material to that, but they have definitely shown an interest in this draft. And then I suppose that would also imply something on the depending draft as well.
Peter van der Stok. I'd like to express my support for this document. I think the intention is good, and I like actually that it gives a role and a possibility to do group communication, so which is very nice. I'm looking really forward to that. I've read an earlier version of the draft. I've not read the aligned version. I'm very happy that you do the alignment. I mean, less standards with the same purpose is very good. So yes, I'm in favor of this draft, but I'd like to reread it once more. Yes. Okay.
Thanks.
Thanks, Marco. Thank you.
Thanks. So the chairs didn't have a good imagination for speakers. So here's the second out of 3 presentations I'm going to deliver today. So this is about key exchange for OSCORE. And OSCORE, as you know, is becoming more and more used. It's adopted by various working groups and in the IETF and SDOs and industry consortia. Now, OSCORE depends on the establishment of a strong master secret. So it's a pre-shared key setting. And 2 alternatives are defined. So you could either do the pre-shared key in some constrained settings that's still a valid deployment, or you could use the OSCORE profile of ACE, which we've been speaking about today. But what is missing for the scenarios where we need forward security is a key exchange protocol. And basically, two alternatives have been raised for how to address key exchange for OSCORE. And alternative A here is that we reuse the transport layer security handshake. So we do some sort of profile of TLS or DTLS at application layer. And there is no such profile at the moment, but there are building blocks. So you could either, one early example of this is the co-DTLS draft, which is doing DTLS over CoAP. And another example is the TLS OSCORE draft, which is specifically addressing the parameters needed for OSCORE. So there are certain, in addition to the master secret, there are two identifiers that needs to be provisioned. And the third option is to look at the things they're doing in the Atlas working group that Hannes announced previously today. So that's a TLS path for key exchange. And the other path is to look at a compact key exchange protocol that we have been developing here in ACE. So it's built on CBOR and COSI. And simple or high-level comparison between the two drafts, or between the two proposals. So TLS, obviously, you know, is built on a well-known theoretical cryptographic protocol called Sigma-I, which is implemented in terms of TLS data structures. Ad hoc is also using the same theoretical protocol, but it's implemented instead in terms of CBOR, COSI, and CoAP, which is reusing the OSCORE primitives. So ad hoc is much more limited functionality protocol. So you could say it's a simpler protocol. It produces smaller messages, as is shown in the next slide. But the main difference between TLS and ad hoc, of course, is the amount of the amount of security analysis that has been behind. So there is still some things that are being analyzed in the setting of TLS, but mainly this is a very analyzed protocol. Whereas for ad hoc, we have just started the formal verification. Yeah, so looking at message sizes, here's a simple comparison between looking at a PSK authenticated Diffie-Hellman, which is the brown or orange in the case of TLS and ad hoc, and the asymmetric key authenticated Diffie-Hellman in the case of TLS and ad hoc. So there's 3 messages and mapping to the 3 messages of the Sigma-I protocol, essentially. So these figures are so this is a fair comparison between the 2 protocols, except that there are some parts missing in terms of OSCORE session identifiers, which is not defined in the TLS, which are not included in the TLS numbers. So you see that there is actually a significant difference in overhead between the 2 protocols. And the simple solution is that TLS was not designed to be a very compact protocol. That was not considered to be very necessary, or whereas ad hoc in the opposite direction is actually precisely looking at the compact implementation. And this turns out that this one reason why this is important is if you look at constrained deployments, which needs a number of round trips to actually carry out a key exchange protocol. And that's the second sub column in each of the columns is illustrating one example. So these are numbers from 6TiSCH. So it's an example of how many bytes you could carry in one frame. So these are making certain assumptions on the actual So overhead used on the link layer in terms of 15.4, 6LoWPAN, and the security on link layer. So with 75 bytes as an example here, you see the number of messages which are needed to the number of frames needed to carry each message around. And we're planning to have a comparison looking at now, if you think about a 6-dish network being deployed, and you start up by turning on the devices, and the first thing they do is to launch a handshake. And these handshake messages are then fragmented, and those fragments are then colliding with each other and creating interference, and you have to sort of see how long time does it take to get this up and running. Unfortunately, we don't have the simulation data ready. We will probably have it in not too long while. But basically, this there is a difference in terms of deployment and what scenarios you actually can deploy with the key exchange protocol. So, and that was basically the background and motivation. And what I like to hear is people's views on how do we progress the key exchange protocol for OSCORE. So we've seen that you can make a more lightweight protocol than TLS, definitely. And you can also create one with lower footprint because you could build it on the same primitives as OSCORE. An important thing is the security analysis. And the issue we've had previously is that people come to us and say, yes, we'd like to make a security analysis of ad hoc. But they also would like to know, how does the IETF position itself with respect to this new protocol? And if we say that, well, you first have to make the security analysis for us, and then we tell you if you're interested or not, then they are not as interested in making the analysis. So it would be good if people think this is a good initiative, that you actually show interest here so that we could try to get out of this catch-22. We already have one university looking at formal verification, but it would be good to have more doing the work. And we think that the approval of this protocol can be conditioned on a formal analysis and finding the issues that are resolved. So you don't need to beforehand approve it just because you accept that IETF is going to work on this protocol. And the final question from my side is, what if we don't want to have a lightweight key exchange protocol, what are the consequences of that? Will people deploy things without key exchange instead, or what would be the options? Okay.
Michael Richardson. I have a couple of points, but I'll address your last one first. The result of not having a lightweight key exchange protocol will be pin 000 that we all use for our headsets for a great number of consumer products. Maybe there are some other places where that won't happen, but I'm skeptical. Then I would like to say that I'm pretty sure we deployed SSL 2 and 3 without a security analysis, and Ike v1 and v2 without a security analysis. And they all came afterwards, to your point. And finally, as I understand, and from reading your documents, you've implemented Sigma I, which is essentially Ike v2. So the security analysis, or the cryptographic community word for what Ike v2 implements, is Sigma I. And that word actually came after we did the design documents, maybe before we actually published them as RFCs, but it happened afterwards. And I understand that your primitives are Sigma I. And so to say that there's no security analysis of your protocol, I think is wrong, because it's simply reinterpreting Ike v2 in terms of CBOR.
Could I ask comment on that? So, I mean, there has been a number of security reviews of the document, but there are no published papers, for example.
Yes.
So if you compare with TLS, there's loads of published papers.
Absolutely.
It's not at that level.
Absolutely. And we should also maybe worry the number of secured papers, that the more analysis things get, the more bugs we find. And it's no surprise that we have to revise protocols because we found bugs. So to expect that a protocol that goes out there has no bugs is to say that, well, I guess we're all running SSL 3, not even TLS 1, right? And that's not true. we're moving really hard to fix those bugs, and that's because we got security reviews. And to say that you have to put the egg before the horse before the cart is silly. But I don't want to rat hole on this. I know it's your issue. I would like to know. Thank you for posting the slide with the PSK byte sizes. And I had difficulty reading it from most of my vision. So I wonder, did you do an analysis with? I'm particularly interested in a situation where one side has a certificate and the other one has a raw public key. And
yeah, these numbers are raw public keys, both of them. So
I thought it said PSK.
That's the blue one, so the blue-gray.
Oh, okay, I understand. So those are raw public key sizes, and what was the overhead? I guess I'm confused how the raw public key can be smaller than PSK then.
You should compare the blue-gray column with the blue-gray column. That would be the TLS and the ad hoc.
Okay, so those are raw public keys. Okay, yeah. Thank you. And what was the key size?
It was a 256-bit EDD. It was ED 25119.
So
if you went to P256, you added about 30 bytes to messages 1 and 2 of the TLS ones.
So that means that the size of the signature was approximately 32 bytes. Is that did I get that right?
I think so.
Yeah, because 256 divided by 8 is 32 bytes.
The signature sizes for ED25519 and P256 are the same.
Yeah. Okay. So just that's the common overhead that you can't get rid of if you use that primitive. Thank you.
Malisha Vucinic. There are 2 points that I would like to make. First, to Michael's point about the consequences of this work being stalled for so long. Ad hoc, I think it's in version 09 right now, and it's been around for quite a while. There were a couple of drafts that were published regarding ad hoc, and then we in Sixtish, we used ad hoc for key exchange during the bootstrapping phase. And with this work being stalled, we had to decide to remove completely the key exchange part and to rely on pre-shared keys from the minimal security draft in Sixtish. So with that, I support what Michael said on the consequences of taking out the key exchange, pretty much because the TLS over proxies is not ready yet and just it doesn't fit our timeline. And then the second point is basically why do we care about the number of fragments that this key exchange protocol translates to? We are using this during the network formation phase or bootstrapping, where essentially this results in slotted log access, and all the nodes contend for the access to the channel, and the probability of collision just raises exponentially with the number of nodes, and you pretty much get a third of bandwidth in the ideal case. You get a throughput that is a third of bandwidth in the ideal case with a larger number of nodes. And to put a figure on this, in Sixtish, this is around 30 to 40 bytes per second.
Hi, this is Hannes. Göran, you have been essentially asking us to re-implement TLS on using a COSI CBOR encoding, pretty much.
No.
And that's how I see it from the exchange. And as you know, like the reason why TLS looks like as it does is because as you go through the standards process, there are different features that are being requested. Starts with algorithm negotiation, it's session resumption. You have all sorts of different functionality. And that functionality then has to be maintained for example, for a company like us. We have to then implement this on the embedded implementation. We have to make this, integrate that into with the interfacing the hardware security. And it already for TLS, that takes us a lot of time. It's a bigger group. And now we essentially have to do that again because you want to shave off some bytes that you think are unnecessary. I would feel differently if the guys who advocate this would actually develop those implementations for the embedded market themselves rather than asking others to do it and then be impatient about why it's not done yet. So go ahead and implement this stuff and make it available.
So, I mean, the people that are working in this, you had Malisha's statement here. He is an example of a person who is actually implementing this and using this. I mean, you have a first step.
So maybe I can comment. I mean, all of this, we are implementing all of this in open source projects that are available, that are used by the industry, that were used in 4 or 5 plug tests organized so far. And to your point about the time that it takes to bring this to market, I think this is an important differentiator among companies. If for some companies it takes several years, for others if it takes a couple of months, then, I mean, you should look elsewhere for what the problem is.
I appreciate your research implementations, but if you want to get something rolled out, I think you are downplaying the investment that you're asking people to do. And I understand that it doesn't take you a long time to write the code in 6-dish, but it takes us a long time to write solid security implementations. And what we've been advocating is to reuse those because of all the investment we've made. And you want to shave off a few bytes and then claim that's a big drama if you add a few bytes more. We have not seen that with many of our customers because they, even, for example, we had all these optimizations for raw public keys and pre-shared secrets and so on. And then many companies still go ahead and use certificates, even fairly large certificates, because they are conservative. They want to use some existing infrastructure. They have a CA infrastructure they want to reuse. Of course, it would be more efficient to strip off all sorts of things, but there are lots of strings attached also operationally that you need to suddenly change. And then people are not doing those, going that step. And so it sounds like, oh, we really need to do something. Otherwise, we go back to Michael's pin 00 example. But I don't think that that's the reality.
So my answer is that the companies that we are working on are completely into the approach we are pushing. And I cannot name because I do not represent these companies, but I guess this is just another side of the medal.
Well, Carsten Moorman, I completely agree that we have to have implementations of this and that we also have to look for production quality implementations. So counting the number of open source implementations is interesting, but it's not the only indicator we need. There's one thing that I would like to point out here. TLS doesn't currently do what we need to do. We need an adapter to TLS to make it do what we need. And I would expect doing this adapter is about the same amount of work, amount of engineering as doing ad hoc in the first place.
The adapter is called key extractor. It has been around for a long time. And if try to implement it, then you see yourself on how much work that is. And it has been used, the key extractor has been used, for example, the DTLS SRTP, because there the same model has been followed. But I'm still waiting to see for people to deploy OSCORE first and then see how that plays out.
Kathleen Moriarty, Area Director. So thank you very much for your work on this and proving out the message size differences, because that was one of the things that you were asked in previous conversations. I don't like how much the work had been held up by this prerequisite that's not normally applied to other work being done. However, you did this work, so thank you. I do think that there is enough room in the billions of devices in IoT for another solution that fits different architectural constraints and device constraints. So I would personally like to see this work go forward in terms of security proofing. I agree with what Michael said. I do think there is room, and if certain vendors don't need this because their devices adequately can handle TLS and existing solutions, that's great. But I think there may be spaces where this is very important for other architectural decisions. So I would like to see this continue if the working group is willing to work on it. And there's plenty of time to figure out what are the architectural constraints for decisions and any other considerations. And there's plenty of time to figure out security proofing as well.
Thanks.
Thanks. We should move on to the next presentation.
Okay.
You can't escape.
Sorry, okay, so this is a very short presentation. It's basically trying to scope what we have done related to the ACE framework and asking the question, how are we going to progress that work? So today we've already spoken about the ACE framework, the DTLS, OSCORE profile, and the keying, the last 3 drafts. And there are 2 more of ACE framework dependent protocols. It's the IPsec profile and the MQTT profile. And the authors are here if you're interested in those drafts. And the basic questions that I'd like to hand over to the chairs to take over this discussion. I just want to introduce the things I think we could think about in completing the work in the ACE framework. Previously, we said we should wait with progressing ACE framework until we have developed profiles and tested it. And that was already discussion previously, whether we are ready for moving on or whether we need to wait profile interrupt testing. There is also the aspect of security analysis. There is a publication or a conference contribution looking specifically at ACE. I don't know if there is a paper yet, but there is a link to the presentation. Maybe there are other security analyses that are made or need to be made in this area. And there is also the other issue which I mentioned previously, but I didn't hear any response on. That's the client authorization aspects, which is not very detailed in the ACE framework. And finally, how should this working group work with this set of documents? Are we going to scope for a particular set of targeted adopted drafts which we complete and then stop the work, or are we open for introducing new profiles? That's it.
Yeah, go ahead. Ludwig Seitz. On the last point, I have a shorter memory. Last point, I would very much be in favor of not limiting us to the 2 existing profiles we have adopted right now, because that's not the idea we had when we designed this whole thing as a framework and then profiles. Because yeah, you could use DTLS and OSCORE, and that covers some use cases, but as Kathleen so eloquently said, there are billions of devices with different use cases. And especially when talking to industry contacts, I've heard MQTT mentioned a lot in the IoT space. So that is a profile I definitely think we should work on. And publish subscribe feels pretty relevant in that context as well. And there is publish subscribe work in core, which is basically the group we're catering for. So I guess there is a number of things I would really like to see moving forward. And I think they're relevant for the industry because the industry does use MQTT, for example. And there are use cases with publish subscribe that I've seen in real deployments. So I think we shouldn't limit us to what we've adopted now unless there is a formal reason why we want to close this working group down. Thank you.
Kirsten, how soon is PubSub going to be done in core? Because I think that there's going to be a normative dependency there, I'm sure.
Carsten Bohrmann. So there is maybe a bit of confusion here about terms. In the core working group, we have a draft called PubSub, which shows one way how multiple nodes can cooperate with a broker to actually get a publish-subscribe-like scenario going. Now, this way of doing things is not a prerequisite to using what is called a PubSub profile here, because the PubSub profile really is about getting the authentication in place for a group. And the group may actually be structured in a completely different way. The way the group is mapped to REST primitives may be done in a different way. And we have heard that we even can use multicast for that. So I wouldn't say the core PubSub document is a prerequisite for the work here to lead to a useful result. Now back to your question, I think there are a lot of people who want to finish this work. And the reason why maybe it has been slow for a while, it started out as a direct reaction to MQTT. So there are various broker-based protocols in use in the IoT, including AMQP, but lots of people think MQTT is somehow important. So we wanted to just write down to show how to solve the same problem using existing core primitives. So that's how it started as a demonstration, as a proof of concept. And then it kind of, well, we had made our point, and the interest in actually finishing it wasn't very high. But I'm seeing some indications that this is now picking up again. I think we will have half a year or so of a lot of interest in PubSub, series transfer, and event streams and related issues. So I would expect that will happen, yes.
Okay, before you sit down, the other drafts that is in core that would be of interest is the multi-us core draft, which is currently an individual draft. I don't know where you feel that one
is. It's adopted. It hasn't been submitted, or has it? It has been submitted. Okay. It was adopted and it was stuck for a while because the submission didn't happen, but apparently it has happened. Oh, has it? Okay, good. So yes, it is a working group adopted document now.
Okay.
So the intent here was to have a little bit of sort of open mic time for people to express opinions. And of course, we still have some more time for that a little bit. We do have a couple of questions that it would be good to ask the working group relating to ad hoc specifically, but I will let Karsten talk again first.
Okay, you just said this is the time to voice opinions. When we started the work that finally led to the ACE working group, we had an idea of the set of problems that needed to be solved. And then in, was it Yokohama, I think, we agreed to use OAuth as one part of solving this set of problems. So I think we have progressed pretty well with that. And I would be in favor of completing a first version of that work to get back to the rest of the problem that we have been trying to solve. So I wouldn't say that the framework document should be the only outcome of the ACE working group, and it should not be the ACE framework, it should be the ACE OAuth framework. And we should do other work to complete the requirements on authorization and authentication that we find in the Internet of Things. Now, what shape that specifically takes, that depends a lot on the point of view, so we will have to discuss that. And maybe the input that went into the Yokohama discussion also is a little bit dated, and we have to update it. But I think we are not done as a working group.
This is Hannes. I'm wondering why a couple of people are talking about done in the working group, closing the working group. Nobody suggested that in previously, at least not to my understanding, because the framework is not finished, the profiles are not finished, other documents are work in progress. So I don't know what you guys are talking about here. It would, however, going back to what Carsten raised on the goals that were set out early at the beginning, I think it's always good to do a reality check after a couple of years, because many things have changed. You know, like this is not work in a vacuum. There are lots of other industry efforts, and what we thought a few years ago on how sort of the whole deployments would look like are obviously a little bit different at this time now. For example, I think back then we were hoping that in the smart home environment, there would be a lot of interest in deploying standardized solutions, and there would be very complicated architectures came from there. It turns out, however, that there's neither interest in a lot of standardized solutions because there are lots of big players battling around there, nor has the deployment gone up to the extent that people had been hoping for. On the other hand, the industrial space saw a more interesting development. And so I think with this reflection, if you look through the use cases, the ACE OAuth use cases which have been, or the ACE use cases which have been published, like maybe we could do a double check on which one of those are still realistic and which one were a little bit more sort of over the top. And then we can fine tune the work that is going on. For example, who would have thought that MQTT would still be so popular after all the core work that we've been doing? You know, we thought that would be dead any day now, but there's still lots of good marketing has been done there.
Yeah, those are interesting thoughts. While we have a bit of quiet time at the mic line, I would like to go back to ad hoc because we did get some very interesting numbers from the overheads. But you know, just sort of as a general prerequisite before any hums, I'd like to get a sense of how many people actually read the ad hoc document. Just a show of hands. There's a goodly number, maybe 15. So that's pretty good. And do a hum for if you are interested in adopting the ad hoc document, and then another hum for if you are not interested in adopting ad hoc. So if you are interested in adopting ad hoc as a working group document, please hum now. And if you are not interested in adopting ad hoc as a working group document, please hum now. Okay, there was some moderate strength hum of support and a lot less against. So that is useful feedback. I'd also like to take this chance to ask about ad hoc. I know we've heard that there are perhaps some business objections about how taking on the ad hoc work would be a lot of work, and you know, there's been people asking for things that are not contributing per se, but I'd very much like to hear if there are specific technical objections to ad hoc that have not been covered already today. So if you do have a technical objection to ad hoc, please come to the mic now.
This is Hannes. I would be interested to see the detailed numbers posted to the list, specifically since the protocols offer different features. So of course they have different message sizes. And I also want to point out that message size is often, while it's often even in t-shirts, promoted as the only sort of real measurement on performance, but there are other aspects as well. There's flash size, there's the underlying performance. So I think we should take that into account as well. To this week, or I think at the next meeting, we talk about EMU, we talk about their EAP TLS, and we add support for that to IoT devices that connect to Wi-Fi networks. And then obviously there's no code sharing possibility, so we double the size, or at least increase it substantially, and so on and so on. These type of things have to be taken into account as well.
Okay, yeah, I'd be happy to see good discussion on that on the list, as well as the numbers themselves. Cool. I do not believe the chairs have further topics on the agenda. So if there is anyone who has an open mic topic, we do still have 40 minutes left in the session.
I will post an article published at the Networking magazine to the list, which unfortunately points out some of the problems that we are running into this IoT space. Namely, there's always a lot of, as you've seen during this meeting, a lot of talk on problems with our work on security. Everyone always complains, too heavy, doesn't work, and so on and so on. Very pessimistic when you read some of the documents. And unfortunately, that's also the message that gets conveyed to people who do not actively participate in the IETF, but actually just follow things along, read some of the documents. And so they come to the conclusion that IoT security, at least from an IETF standpoint, is far from being deployable and ready, which is a very unfortunate message because we've done a lot of work during the last couple of years. And so they suggest to vendors, wait a little bit, let the IETF figure this out first before you actually go and deploy something. I would post you one of those articles. It basically portrays a slightly different picture than Michael has been mentioning beforehand. So with that,
thanks.
Kathleen Moriarty, Area Director. So I don't think we've heard enough serious technical objections, and I just want to confirm your next step is to put this out on the list so that we don't delay further and we look for all of that. I just wanted it said in the meeting. Thank you. I figured it was your next step.
Yeah, thank you.
So I don't know how we're going to continue. This discussion has been going on for a little while. We had the raise of hands a year ago on ad hoc, and it was 15 hands also showing interest at the time. But I just want to point out that this is not about replacing TLS. This is about addressing certain use cases where we need a key exchange protocol for OSCORE that is efficient for that type of constrained deployment. So whereas this could be painted as we're going to have double stacks everywhere, or we're going to replace well-proven protocols, that's not the intent here. We're looking at the set of use cases where a profiled protocol, which does not have at all the same features as TLS, is doing the key exchange, providing the forward secrecy for the keys that we need. So that's essentially the proposal.
All right. Thank you, everyone, for your comments and feedback. If no one is, oh, Hannes is jumping up to the mic. You're leaving? Okay. Yep. Thanks, everybody. We'll finish half an hour early. If you have not signed the blue sheets, please come up and find the blue sheets.
Since this is being photoed out several times, I just wanted to show my face and say hi. I'm not too sure. I'm just sensing the group that how we go eventually, whether it would be interesting but you're here to answer, yeah, questions. Yeah.
Part of it is.
Okay, I was just, this is 15 production. We are here, we're working on it, and we could be, stepping up to do more work necessary. And we've published in the weekly also due to a